Yes. Well.
Tracy, unmute yourself.
Lord bless you and keep you. Make his face shine upon you. Be gracious to you. Light up darkness. Praise to you.
Always remember one thing, on the road to success.
Hey guys, give me a minute. I'm trying to set up a board for us to be able to do some tests. Okay. Can you guys hear me? Right. You all have the slides for today, yes? Chapter 7. I sent it to you guys yesterday. So please open that file. Okay. So today what we want to learn is data flow diagram, okay? How to plot data flow diagram. So let me just share the screen. Desktop, parallel, Windows parallel desktop. 4 points, no? Which is it? Okay. Can you see my screen? All right, so we will just quickly get to it. So today what we want to learn is the data flow diagrams, how to plot data flow diagrams, how to define where data comes from and where data goes to and where data is being processed. All right, so data flow diagram, how to draw. Basically today, I hope at the end of the class, you have an idea how to draw data flow diagrams, okay, as tools to support analysis of information system. Okay, so remember yesterday we talked about requirements determination, how you can find out requirements for a system and how you can do that. One is through interview, another one is through observation, another one is through prototyping, another one is through document analysis. Okay, today we want to talk about the requirement structuring. All right, how do you, when you get your requirement, how do you structure them? All right, so you structure them through process modeling. You model the process, okay? And graphically represent the processes that capture, how do you capture, manipulate, store, and distribute data between a system and its environment and among system components, all right? So utilize information gathering during requirements determination. That information you gather during requirement determination, you will use it to graphically means in picture form or in drawing form, okay? You represent the processes. Represent the processes that capture. How do you capture data? That data, how do you manipulate the data? After manipulation, how do you process the data? How do you store the data? Where do you store the data? And how do you distribute this data within a system? Who uses the data? Who receives the data? Who processes the data? Where does the data go? Okay, you need to graphically represent this data from source to sink or file, okay? Between a system and its environment. The environment of a system includes the people using the system, okay? And the system components, different parts of the system, all right? So the processes and data structures are modeled. What are the processes? Example, I'm hungry. I tell my mother, Mom, I'm hungry, I want food. See, I've given my mother data, information. I have made a request that I am hungry, I want food. Now, my mother will have to process the information, okay, in the kitchen by cooking, right? And then from the kitchen, the output will come out, which is food, and it will come to me. So you see where data goes, where who receives the data, where the data is processed, and then maybe also where the data is stored, maybe in the fridge or in the store. Should get some raw materials and add it to whatever she's doing in the kitchen, process it before the output will come out back to me as food for me to eat, yes? So in data flow diagrams, okay, there are several stages of data flow diagram. Okay, stage 1 is context diagram. 1 second. Okay, I think the noise is better. Context data flow diagram. So context data flow diagram is the first stage of data flow diagram, okay? After you draw your first stage, okay? Just like I explained, Mom, I want food, okay? Then the food is being processed in the kitchen, okay, by Mom. So we have Mom, we have kitchen, we have me, we have Mom, we have me, we have kitchen, we have Mom, okay? So Mom, kitchen, me, kitchen, Mom. And in this system, cook food. We don't want to know how she cooks the food. Basically, we just know that cook food, Mom, me, right? This is context diagram. So context data flow diagram, the first stage. Now, in the next stage, which is the data flow diagram level 0 is the next stage. So we break this cook food into more processes. Example, maybe boil water, add noodles, some other processes. That is the next stage. And then the next stage after that, she also break that sub processes into more processes, okay? We will understand that better as we move forward, okay? So here, the current physical system adequate detail only, okay? In the context diagram, you only need adequate detail only, just enough information. Don't put too much information in the context diagram, okay? It enables analysts to understand the current system, all right? So data flow diagram is the new logical system, all right? Technology independent, all right? You don't need technology in data flow diagram. Like you don't need hardware, software, all these things. No, what we just want to see is the data flows, the structure, the functional requirement of the new system, all right? There will be a complete, thorough description of each data flow component, all right? It represents both the physical and logical information system. Now, in the context that in data flow diagram, what you use to draw data flow diagram is only 4 symbols. 1, 2, 3, 4, 4 symbols. What are these 4 symbols? One is the process, okay? Process, example, cook food. This is a process, okay? Cook food is a process, all right? Another one is data store. Data store, this is how you show data store, just like database or your file. Okay, cook food, example, this fridge can be a data store, right? The refrigerator can be a data store because after you cook the food, if you do not finish, you can put it in the fridge, right? And you can put some of the, so this is where you store data. Example is fridge. I'm just giving a scenario, but obviously in information system, you don't have fridge, right? You have maybe file or something, database or file, repository, okay? Data store. And then this is source and sink. Source and sink, source means where the data come from. Sink is the person that received the data. Example, me. I am the source because I told my mother, Mom, I'm hungry, I want food. So the information came from me. I am the source. You see the direction of the information. It came from me out. And sink is the person that received the information, which is my mom. Okay, so it is being depicted by the same rectangle, but the difference is the direction of the arrow. If it's this way going out of the rectangle, it means it's a source. If it's this way going into the rectangle, it means it's a sink. And obviously your arrow shows the direction of data, which direction the data is going, all right? As you can see, the arrow is going this way, and this arrow is also going that way. And remember, every arrow must be labeled, okay? Every arrow must be labeled. Like this arrow now will be request food. Sorry. Request food. And this arrow will be receive request. Receive request, right? Okay, so when you're drawing your data flow diagrams, these are the symbols you need to use, okay, to draw your data flow diagrams, all right? So let us look at what processes are. A process, obviously, just like I explained, is the work or action done on a data inside the system, okay? You receive data, what happens to the data? The data is being processed, okay? So that processing is what is called process, okay? Data store. Data store is where the data rests inside the system, like a file or database or repository, okay? Source and sink, I've explained it, external entity like me and my mom. That is the origin where the data came from, or the destination where the data is going to or being used, okay? Outside the system, okay? Of course, my mother is the destination, even though she is outside the system, because a destination inside the system will be a data store, right? Or a repository or a file or a database or something like that. All right. Okay, let's get back to what we were doing. Data flow is arrows depicting movement. All right. So context diagram, like I explained, this is the first level. It's an overview of an organizational system that shows the system boundaries, external entity that interact with the system. The major information flows between the entity and the system. It shows the major information flow or move or go between entity, me, my mom, and the system. The kitchen is a system where food is being cooked or food is being processed, right? So only one process symbol and no data store is shown in the context diagram, all right? So I set up a screen here. I don't know if it can be seen. I don't know if you guys can see my video. Okay, so what happens here is in your context diagram, you have basically one process. I don't know if you can you guys see? One process, one entity. Okay. How many entity depends on the system, on the what the system is saying, but usually you only have one process. Okay. So let us move back to the slide. And then, because I want to do some drawings for you guys to understand clearly later. Okay. All right, so this is an example to illustrate how data flow diagrams are used to model the logic of data flows in information systems. We will represent the walkthrough and walk through an example. Okay, consider this burger shop. Okay, or Hosea Burger. Okay, it's a restaurant in Indiana owned by this man. All right, so people believe that this is the best burger in Indiana. So this information is not important. So, okay, this is where data starts from. This is where you have your information. All right. So what does it say? The restaurant uses information system that takes customer orders, send the order to the kitchen, monitor the goods sold, and inventory, and generate report for the management. Okay, so look at this scenario now. And you will notice that there are how many entity, external entity? Customer, kitchen, restaurant manager. Restaurant manager, customer, and kitchen, which means we already have our 3 objects. Okay, we have our 3 entities, which is first one will be customer, kitchen, and restaurant manager. Restaurant manager. Okay, so what happens here? What exactly happens here? One, you see the restaurant uses an information system that takes customer orders. Okay, so here we say restaurant information system. You can call it whatever you think is the best name to do, to use it for your context diagram. Okay, restaurant uses an information system that takes orders from customers. Okay, so which means customer make order. Can you guys see this note here on the side? Can you see what I'm writing? Because if you cannot see what I'm writing, then I think it's useless. Can you see what I am writing? Almost. Almost is not good enough. Okay. Okay, give me a second. Let me get something. Okay, how about now? Can you see what I'm writing? Because I don't think I want to use the screen. Next class, I'll set this up better. So let's just try and focus and see. So basically we have, all right, I can see it clearly from here. So you have the customer, you have the restaurant information system, and you have the kitchen, all right? So, and then you have your restaurant manager, okay? So what does it say? It says it takes orders from the customer, send the order to the kitchen. So you see this arrow, it says make order, customer makes order, okay? Then see, it sends the order to the kitchen, which means this arrow is wrong. It should not be going this direction. It should be going this direction. Send order, send order to kitchen, okay? And then it says it monitors the goods sold in the inventory and generates reports. So this is still the restaurant information system. All these processes are happening in here. We don't have to have many processes. We just need one process in the context diagram. Okay, we just need one process. And this is the first level, usually depicted by 0. Okay, the single process is labeled 0 and represents the entire system, which is one process, which represents the entire system. So everything happening inside the system, we don't break it down in the first, in the context diagram. And then it says generate report for management. So generate report. Can you see? And this is our complete context diagram. From customer, make order to the restaurant information system, send the order to the kitchen, okay, and generate report for management. This is context diagram. Now, the next level, remember, I told you level 1 is context diagram, level 2 is data flow diagram, level 0, even though it's level 2, but it is called DFD Level 0. Level 3 is called DFD Level 1. Okay, so what happens in DFD Level 0? You break down the first process into extra processes. Okay, what happened into DFD Level 1 is you break down that extra process into more processes. Okay, let us look at what we mean by that. Okay, so, okay, we also have, obviously, when the food is complete, the restaurant will give receipt to the offer receipt to the customer. Yes, and this is the context diagram labeled by level 0. Do you understand it up until this point? Tintong lama? Now, if yes, we proceed to the next level, level 0, DFD level 0. Okay, do you understand it up until this point before I go to the next level? I go to the next explanation. Or do you need me to explain it one more time? Okay. Now we'll look at data flow diagram level 0. What happens in data flow diagram level 0? Okay. It is a data flow diagram that represents a system major processes, data flow and data stores. So now you will need to add repository to the repository and all the major processes in the data flow diagram, okay? And remember, in our context diagram, it is labeled as level, it's labeled at 0. The process is labeled at 0, as 0, which means the next level, the processes will be labeled 1 point, no more 0, 1.0, 2.0, okay? So let us look at an example so that it will give you clearer understanding. Okay, so I think this should be better now if I do it this way. Okay. All right, so in the next level, all right, what happens is obviously we still have our customer. We have our kitchen. Okay, and then what happens in that process? The first process will be, because now we don't want the entire system, we want to break down these processes into smaller processes, okay? 1.0 now, receive and transform. Okay, so let us look at this slide so that we will compare it with this other receive and transform order. Receive and transform order. Okay, I think this is too small. Maybe we'll make it bigger. Customer, kitchen. Okay, receive and transform order. This is the first process. And you name it as 1.0. Okay. Now, what happens to this process? You remember, send order or make order. Okay. Receive customer order. Okay. So what happens? We have broken this first food ordering system. This is one process, but we know that there are many processes inside this process, right? We want to break it down into simpler processes. That is why it is called the next level, right? So what happens in this process? The first process is you receive and transform the order, right? So once you transform the order, according to what was said here in the explanation, all right, the information system takes order and sends the order to the kitchen. It monitors goods sold. This is one. It also monitors inventory. This is 2. So we have monitor goods sold as one process. 2, this would be 2.0. Monitor process, and we monitor goods sold, and also monitor inventory. 3.0, monitor inventory. So what's the difference between goods sold and inventory? Goods sold, every day you want to know how many things you sold, right? And obviously your inventory, you want to know how much goods is left inside your inventory, because you don't want customers to come and then you are out of stock, right? So you monitor the goods sold, and you monitor the inventory, okay? So once what happens here now, this process obviously have to check information from a database, right? It needs to check and update information from the database, monitor goods sold file, okay? So goods sold file. This also needs to update information in the database as well. And this will be inventory file. Inventory file, right? Can you see? I hope you can. Okay, I think it's better now. Okay, so, and to generate report for the manager, just like this slide says, restaurant manager, that's our final entity, external entity. Restaurant manager, right? So it has to get information, data from the database of the file, or the database of the inventory, and also the file from the goods sold file, okay? To generate reports, sorry, this cannot go directly. I will explain this later. File, they cannot interact directly with, two external entities cannot interact with themselves. There must be a process in between. So this process will be called 4.0, generate report. Generate report. So this arrow goes this way instead. Okay. The file cannot interact directly with the manager. Instead, the process will. Okay, so this arrow, you need to label it send goods sold data, and send inventory data. Inventory data. Send inventory data. You must label all your arrows, okay? Okay. Send report. It's just the basic concept I want to teach you. Hopefully you can understand. Okay. Send goods data. I'll call this send goods data. You can label it what you feel. You as a system analyst will be the, can name it based on your personal understanding. Here they named it as goods sold. Goods sold. And inventory data. So if you see, what is the difference between this diagram and this diagram? They broke down this process into more processes, 4 processes basically, okay? Receive and transform, order, goods sold, inventory sold. Monitor goods sold, the process goes to goods sold file. Inventory data goes to monitor inventory. When you monitor inventory, maybe you update the inventory or whatever, and then update the inventory obviously in the inventory file. Update the inventory in the goods, update the goods in the goods sold file. So now in order to generate report for the manager have to generate the report from the database, just like if you are checking your Excel or your Access, or you generate a report. I think we did that in our first lab in the other course, MIS, right? So you generate report from database, and that is the process. After it's done, it sends the report to the restaurant manager. So this is called the data flow diagram level 0. So you as the system analyst, do you think you can break down any of these reports process into more processes? If your answer is yes, that means you need to have another level 1. You need to have DFD level 1. Okay, so let us say which of these processes can we break down, okay, into more processes. I can say maybe we can break down this generate report into more. How can we break this down? Maybe what are the processes in here? We can format the report, okay, which is one process. You format the report. We can print the report, which is another process. You can see. So that means we will now have 4 points. In the next DFD diagram, it will not be 4.0 anymore. It will be 4.0.1 because it is this particular 4.0 process that is being broken down into extra level. Okay, so let us look at okay, they didn't give illustration. So basically, that is the concept. All right, that is the basic concept. Okay, so let us look at the rules for drawing data flow diagrams. Okay, what are the rules you must pay attention to when you are drawing data flow diagrams? Okay. There are 2 data flow diagram guidelines that appear. The inputs to a process are different from the output to that process. Okay, the input to a process is different from the output to that process. What do I mean? The input to this process is send order. The output cannot be send order also. It must be different, okay? And you must label your arrow. You cannot say send order, and after the process complete, the output is also send order. Impossible, okay? It must be different. Process's purpose is to transform input into output. Okay, we've explained that. The objects on data flow diagram have unique names. Okay, every object have different name. You cannot have multiple objects having the same name. Example, customer, and this one is also customer. No, it has to be different. Restaurant manager, right? All your have to be different. So let us look at the rules. Okay, there are rules that you need to remember when drawing your data flow diagram. If you remember, I made a mistake here connecting this to this. Why did we cancel it? Why? We will see it in the rules, okay, and understand it better. Number one, no process can have input only. Okay, no process can have only inputs. That is, example, this is a process and information coming to the process, but there's no output. Impossible. Okay, so it must have input, it must have output. Okay, unless it is a sync or file. Okay, if it is a sync or file, then it have input but no output. But if it's a process, it must have output. Okay, the same thing applies to this. No process can have output only. It must have input and then output. Okay, that is a rule. It's just common sense. Remember that, and you will use it to draw your data flow diagrams. Okay, another example. No repository or file can interact directly with another file. Okay, there must be a process in between the two files before it can be correct. If not, your data flow diagram will be wrong. Okay, the same thing, we cannot interact with file or repository. Okay, there must be a process in between. This is exactly the reason why we canceled this, because this is a sync, this is a file, this is a sync. It cannot interact directly, impossible. There must be a process in between. So this process send inventory data. Okay, it now being processed here, generate reports, and then send reports to the restaurant manager. Do you understand? Do you understand that rule? Okay, so I'm trying to be as clear as possible so that we will not have to, it will not be difficult for you to understand. Okay, so we will take 5 minutes break after I'm done with explaining these processes, and then we'll come back, but let me be done first. Okay, so we've already explained file cannot interact with sync, or source cannot interact with file. File cannot interact only directly with sync. Sync and source cannot interact directly. That is, customer cannot interact directly with kitchen, right? There must be a process in between. Okay, exactly like we have customer, transform, receive, and transform order, and then kitchen. And then, okay, you cannot have arrows going in double direction. Example, you cannot have an arrow like this, double end arrow, and then you name it with one name, send order. Send order, where is it going to? This direction or that direction? This direction or that direction? Okay, you cannot name it like that. Instead, you must have two arrows going different directions with different purposes. Okay. Instead, you have to have two arrows going. So you cannot have one arrow going both directions. You need to split it into two. So one arrow is going this way with one message, and the other arrow is going this way with another message. Okay. And so let's proceed. Okay. So a fork at a data flow means that exactly the same data goes from a common location to copies of the same. Oh, okay. Yes. We can take 5 minutes break now. Actually, 3 minutes break, and we will continue after the break. All right. So I will just stop here. All right. Can we resume our class? Can we resume the class? Hello? Anybody home? Ni hao, ni hao. Okay, great. So, the next rule has to do with how data flows, okay? How data flows, okay? So, example, you can have you see, I hope you can see. So on your screen, you can try and enlarge this other screen that shows the paper so you can see clearly, make it big. Okay, so you can have, for example, one process. You can have one process sending the same data to two different locations. The same data being sent to two different locations. It's allowed, okay? But it's only one data you are sending to two different locations, okay? That is, maybe the data is A. You're sending A to whether it is a process or a repository, it doesn't matter. Okay, you can have same data being stored in two different places or being processed by two different processes. But you cannot have A and B on the same line. Okay, you cannot have this. This is wrong, which means you cannot have this like this. You have to only have one going this way, A, and another line going this way. You have to split it, B. Okay, you cannot have this. This is wrong. Unless it is only one data going in both directions. So this is what this is saying. You cannot have A and B on one, but you can have A going in both directions. The same thing also in terms of receiving data. You cannot have a process and an entity both send. You can okay. You cannot have. You can have these two arrows sending one data, which is A. Okay, you can have, it is allowed, but you cannot have both of them and then you are saying A and B, A plus B, two different data, and you're drawing it like this. No, you cannot do that. You have to draw it on two different arrows. If you're drawing it on one fork arrow, it means it is the same data. All right, and also you cannot have a process as an output of a process also equal to the input of a process. You cannot have this. Okay, you cannot have data going out of a process and going back into the same process. This is what this rule is saying. You cannot have this. No, there must be another process in between. There must be another process in between. Then this is input to this process. After it is being processed, it comes out as output. You cannot have one. So these are the rules. They are very simple rules, but logical rules. So if you remember these rules, you can use it to draw any data flow diagram I ask you to draw in the future. Okay, So let us proceed. Functional decomposition. What is functional decomposition? If you know the word decomposition, it comes from the word decay. Okay, when an organic material like plant or animal or whatever, when it dies, you bury it or whatever, it will decay or rotten. Okay, and basically what this is saying is breakdown. Break down. Breakdown. So what happens in functional decomposition? It basically means from your context diagram, right? The first level, after you're done drawing your context diagram, you need to break down if the processes are more. Break it down into simpler processes. That is why we go from context diagram to data flow diagram level 0. What happens in that context diagram process? It is functionally decomposed. You break it down into smaller processes. And those processes, if you think you can break it down more, you functionally decompose it again to DFD level 1, DFD level 2, DFD level 3. So that breaking down into simpler processes is what is called a functional decomposition, okay? It is an iterative process of breaking a system description down into finer and simpler details, okay? It creates a set of charts in which one process on a given chart is explained in greater details on another chart, okay? One process is broken down and explained in greater detail, in more detail, okay, on the next chart or the next DFD level, all right? This continues, you continue functionally decomposing each chart until all the process cannot logically be broken down further, okay? You've reached to the final process where you don't think any more process can be done. Then you stop there, all right? So DFD level 1, okay, is the result of DFD level 0. DFD level 0 is the result of functionally decomposing context diagram. Okay, so what is this saying? The first level is your context diagram. Context diagram. Okay, when you functionally decompose your context diagram, you have your DFD level 0. When you functionally decompose level 0 DFD, you have DFD level 1. When you functionally decompose DFD level 1, it goes on and on until DFD level N, depending on how many processes, 10, 20, depending on you, okay? How many processes you think you can break it down into, all right? So an example. This was, what is it called? DFD level 4.0. Now we can change this into so basically what you're seeing here, okay, daily goods sold amount, okay? This process, they are functionally decomposing this process, this 4.0 process. So basically you will draw this entire thing again. That is if you're not breaking down these processes, okay? But when you come to this process, okay, let me just draw it so it will be easier for you to understand. So this is DFD level 1, right? So now we are drawing DFD level 0. And what happens here? You have your customer. You have your kitchen. Okay. You have your send order, receive receipt, send order, receive order. Then you have your first process. .0, then receive and transform order. Let's okay. Then it goes on to the next process. All right. Here you give the goods sold data. Goods sold. Okay. Goes to that 2.0 process. I hope you all can see. Okay. Monitor or update goods sold. Okay. And then you have your inventory data. Okay. 3.0. Update or monitor inventory. Okay. So what happens here? Okay, let us say, right now we are not considering breaking down these processes, okay? It can be broken down, but that is not our focus right now, because I want to focus on breaking down that process number 4, so you can understand what it means by functionally decomposing from level 0 to level 1, all right? So this goes into file. Goods sold file, GS file, okay? And then this goes into inventory file. Okay, this goes into inventory file. So that process, this particular process from DFD level 0, generate reports. Now we will not use generate reports because we are breaking down this process into smaller process. Okay, so what happens with the first process after breaking down? This will become 4.1. All right, it will become 4.1. So 4.1 will be access goods sold, and inventory. Shortcut. Access goods sold and inventory data. So it comes from these two files. Can you see that first process? Now it comes from these two files: access goods sold file, data, and inventory data. Then this will be daily, because it is every day, right? Daily sold amount, daily sold or daily goods sold amount. Okay, remember, I did not just use goods sold, because this arrow, if I say goods sold, it will be the same thing with this arrow, goods sold. Okay, try not to use the same name for different arrows. Okay, try to use different name. The same thing with this one, daily inventory amount. Okay, now from here, that process is being broken down into 4.2. Which is aggregate or total. Aggregate goods sold and inventory data, or total, or calculate goods sold or something. Okay, aggregate your sum goods sold, or whatever calculation you want to do, just like we did in Microsoft Access, in order to generate the report, right? You aggregate the data, and then you go to 4.3, prepare management report before you give it to the manager, restaurant manager or general manager. Let's just use, okay, no, you cannot have different name, okay? You cannot have different name from different level, okay? Like in your context diagram, the name is customer, and then next diagram, you're changing it to client, okay? Don't do that, okay? You be consistent, all right? You must be consistent. So let us, okay, if you see here, now they have also, okay, 1 second. This is repair management report. Now, repair management report, this is 4.3 in level DFD level 1. You can also break this down into DFD level 2 if you feel some processes can also be broken down even more. Example, repair management report. This is what was done here. DFD level 2. You see, this repair management report now has changed from 4.3.1 because they want to format the data and print. So 4.3.1 will now be format, instead of just prepare the report, but something can, there are many processes inside prepare report, right? So they want to show those processes. That is why you break it down into the next level. Format management report. And then formatted data, print management report. You see, there are 2 more processes inside that initial process. So this is what is being done when you break down processes from one level to the other. Okay, so I would not go through this entire slide because I want to give you guys one exercise to do in the next 5 minutes. Okay, so conservative principle means that conserve the input and output to a process at the next level. This is what I just explained. What do I mean? In your context diagram, you have customer and you have kitchen, right? And suddenly in your next DFD level 0, you're having multiple inputs and no output, or different sort of output. No, you have to be consistent. That is what it means to be conservative and balancing. Conserve the input and output of data flow diagram process when the process is decomposed to a lower level. right? This is just what it's saying. When you're going to a lower level, you need to be consistent. Your kitchen must be kitchen in the next system. Your customer must be customer in your next, but you can have different, you're breaking down the processes. These ones can change, but not your external entities, all right? So splitting, data splitting. I've already explained this. So these are all rules and rules and rules. So we will go through all of these in the next class, because I think we have explained enough today. So using the example of retail, okay? So this is for customer, okay? But now I want you to, how many of you know this restaurant called H&M? Not restaurant, store. It's a clothing brand called H&M. How many of you know this clothing brand? What are the popular clothing brands in China? Like in Malaysia, they have, okay, even some of the stores here in Nigeria, we have H&M, we have Cotton On, we have Padini, we have, I can't remember. But let us just say example, H&M is a clothing brand, okay? You go to this store, H&M store, to buy clothes, okay, in the mall, okay? List the relevant data flows, data process, source, and sink, okay? And then observe several sales transactions. What happens? Okay, now I need you to create the idea from your mind, okay? Draw a context diagram, level 1, that is the first level, and then level 0 diagram that represents the selling system at the store. And pretty much this is the question I want you to do, okay? In groups, and I need you to do it very, very, very fast as you can, based on your understanding, okay? So what happens, you go to a mall, you as the customer, you make an order, or you, based on your understanding, okay? What happens? Okay, I want you to list data flow, data process, and source, okay? I don't need you to go up until level 1, level 2, level 3, level 4, many details, just the 2 first level, DFD, level 0, and then the first level context diagram, all right? Based on your understanding. So you can all start your exercise now. Do you understand my question? Do you understand the exercise? If you don't, let me know, I will explain again. Do you understand the exercise? Hello, nobody is saying anything. Do you understand the exercise? Okay, good. So start. You have 5 minutes. Customer, restaurant, maybe you want to have a salesperson, that depends on you. Maybe you want to have a store manager, that depends on you. What process, that depends on you. You as the system analyst, you need to be able to analyze how data flow, where it rests, who is the source, who is the sink, who is the file, okay, based on your understanding. No, please. You have 2 minutes. Ahmad, no, I asked you to draw context diagram and DFD level 0. Obviously, your context diagram will have only one process, right? And how many entity depends on you. That particular process, I want it broken down into the other processes, just DFD level 0, okay? You have 2 minutes. You should be done by now. You're still asking me questions. Okay, your time is up. Let me see your path. Share it with me. You guys are not on Skype yet. You could have just shared all your files on Skype. Cyrene, you really need to create that Skype as soon as possible before the next class. All right, please. Can you attach files on Zoom? Take a picture and share the picture on Zoom on the chat. Participants. Something always come up. Mute themselves. Please attach your files quickly in the Zoom. Let me see. Hurry, we don't have time anymore. I want to see what you have, your context diagram. Take a picture and did you draw it? Or obviously you draw it on a paper. So take a picture. Send it to your, I don't know, your computer, your phone, what are your device? And the chat box here, there's a attached file there, just above it, your computer, and you will attach the file. I want to see your diagrams so we can comment on it, because there is a homework at the end of this class. So at least when you do your exercise, you can get some ideas to do your homework. This is the homework. You need to choose one of these two and draw your diagrams. Oh my goodness. Should be on WeChat. I don't have much use for that WeChat ID, do I? I'm waiting. Why? Participants can choose everyone publicly. See that, I think. Really? What are my options? Is it on your screen? Okay, what is gonna happen now? I'm going to move hosts to each of you group by group. You move the hosts to the next group, move the host to the next group, and then you can, I don't know, share your screen or something. All right, so let me start with you, 3C. I will make you the host and let me see what you have. Tracy, where are you? Okay. Okay, Tracy, I have made you the host. Cyrene can attach. Why can't you attach? I've seen Cyrene's file. Cyrene. This is for the inventory record. zero layer figure. Okay. This is your retail ordering system. Load order, customer order, warehouse manager. Okay, this is good. Context diagram. Let me see your DFD Level Zero diagram.
Teacher, we didn't finish the second one.
Okay. Cyrene, I don't quite understand your, you didn't follow this process I asked you to follow. Okay. Anyways, when you finish it, you can send it to you guys. We don't have a group to chat on now. I'll try. If we had a Skype group, it would be very easy for me. Okay, what is going to happen is follow the process that we used to, because time is up, we need to end the class now. We used to draw our context diagram and our DFD diagram, okay? And try and answer the, what is it called? The homework, okay? There are two scenarios that are there. You choose one of the two scenarios as a group and answer it. Whether it is on Skype or it is on WeChat, I'll try, and if Cyrene creates the Skype group today, or if I'm able to fix my WeChat, then you can send your exercise to that group. Then we can discuss each of your answers, and so that I can give you feedback. So with that feedback, it will help you have a better understanding, and it will help you do your homework better. So I'm expecting this homework. When is our next class? Our next class is Monday, no class. Next class is on the 8th, which is Tuesday next week. So I'll see you guys all on Tuesday. Yes, Cyrene, if for your exercise, I'm saying you need to send your exercise. We need to discuss on your exercise, your class exercise, so that I can give you feedback. But for the homework, you submit the homework in the next class, before the next class, just before the next class, okay? Which means if you finish your homework today, send to Cyrene. But by the beginning of the next class, which means you are late, I won't accept your homework when the class starts. So before the class will start, Cyrene will send it to me. That is, your deadline is 1 p.m. Beijing time. Our class will be around 2 something. On Tuesday, before 1, you need to send it to her. After 1 o'clock, you are late. And she will send any file that is with her to me. Once she does that, you are late. You cannot do that anymore, all right? So I'll see you guys all next week, all right? Bye-bye.